Hello everyone, in this video we will be discussing about the shear force as well as bending moment diagram of the fixed beam. So far we have seen the cantilever, simply supported beam, overhanging beam. So this is the last topic in which we will draw the SFD and BMD of fixed type of the beam. So first thing is that how such type of beams are different from the previous beams. In this case you will be finding that here at the end supports there will be generation of the moments MA and MP at these two junctions. So that is the other thing that in this case there will be the end moments that is denoted by MA and MB, and at the same time the whatever the slopes at these points will be zero at these 2 points. So in this case of the fixed beam these two things will be just remember that here the moments will be at MA and MB, and here the slope will be 0. So that is actually basically indicated by a flat line over here, which indicates that the slope here is 0 and this the moment here is in anti-clockwise and here it is in clockwise direction. So these two major changes are in the case of the fixed beam. Simultaneously, if you want to find out the SFT and BMD of such type of the fixed type of beam, then some consideration and certain assumptions are to be made if you want to just draw the SFD and BMD. The first thing is that we will just break down such type of the fixed beam into the two beams. One will be the simply supported beam on which only these vertical loads or UDL or UVLs will be acting, and the other will be a beam on which over the end moments will be acting, and we will be compiling both of these moments and will be generating their BMD, and simultaneously we will do that for the shear force diagram. So here you will see that when we are just drawing the SFD of the beam which is having the moments of MA and MB, so here basically hogging moment will be there which is negative in sign, and due to this anti-clockwise and clockwise moments end reaction R is generated over here, which can be determined by using this equation which is shown here. So these are the things. So if we just go through, so here you can see that if we just overlap both of these bending moment diagram, this trapezoidal type is due to the um, and this is due to the vertical load, and this MA and MB type which is in trapezoidal shape, this AHJB, that is due to the moment. So if we just both superimpose with each other, then we will get negative, positive and negative. This is the BMD diagram. Simultaneously we can also draw the shear force diagram if we know this end reaction R, as well as when we assume this to be a simply supported beam. So if we use these two things, then we can draw such type of SFD and BMD. Let's see a case in which we have W full load is acting on this fixed beam having at a distance of L by 2. So here we will be considering it to be a simply supported beam, and beam which is having a moment of MA and MB at its end support. So if we are acting, if center force is acting, then its bending moment will diagram will be like this, and if the end moments will be acting, then its moment diagram will be like this, which is having an end moment of MA and MB of the value WL over 8. So in this case both will be superimposed with each other, and then we can draw this SFT diagram whose end reaction will be W by 2 and W by 2. Since both these moments are equal, therefore whatever the end reaction will be generated, both will cancel out each other, and whatever the SFD that will be obtained, that will be of a simply supported beam. Simultaneously, if load is acting at not at a center, at a certain distance of A from this support A, then also we can just work out the formula, and then we can find the SFD and BMD of such type of beam by assuming it to be a simply supported beam. Then it will form a triangle like this, and then a trapezoidal for the CF bending moment diagram for the beam having a moment M and MB acting at the extreme ends. So in this case we can find out the moments which is acting on a particular beam only if we equate the area of the triangle and the area of the trapezium. So if we equate both of these area together, then only we actually obtain the end moments. In this case, let's say if we take example of this, when we equate the area of this triangle and this rectangle, then we get WL over 8. Similarly, we do same thing for this case also, and we do again for the UDL and UVL cases also. Simultaneously, we can just work out the formula, and here we can get the formula for moment at A is equals to WAB square over L square. Similarly, the moment at B is WA square B over L square. When we use this formula, we will calculate the end moment, and then we will draw the bending moment diagram using that formula. Simultaneously, we can work on this numericals, and we will use the same formula to draw the SFD as well as BMD of such types of numerical. Let's see if this is the numerical, then we will be just breaking it out into the simply supported beam. Then we will use WL by 4 formula, and then we will just draw this its bending moment diagram. Then we will use the formula and calculate MA and NB. Then we will get this formula, and if we know the end reaction, and then we can calculate the end reaction RA and RB if we know the end reaction R, which is due to the moment. So by putting both of this value, then we can calculate this RA and RB value, and then we will just RA and RB value, and then we can just draw its shear force diagram. The same we can do for the UDL cases also. This is the case of UDL. Similarly, we will break down into the case of the simply supported, and these are the end moments MA and MB, which is acting at its extreme and which will be equal to each other. So they will cancel out each other. Therefore, the value of R will be 0 over here, and we will only get the value of RA and RB, which is the same as that of the simply supported beam, and this is its bending moment diagram. So this by this way we can draw the SFD and BMD of certain type of the fixed beams. And in this case we have other type of beam that is a continuous beam, but that is not in our syllabus. So we will keep this second unit till here, and in the next video we will start our third unit. Thank you.